present here. For this today's lecture, we are going to discuss about the topic similitude. In the previous class, we have discussed about method of dimensions, in which we have completed Rayleigh's method, repeating variable. In this, we have discussed three repeating variables selections. That is, one is geometric property, and one is of flow property, and another one is of fluidic property. In geometric property, we have to choose either length or height or diameter or depth, like that, right? In flow property, we need to choose velocity or acceleration. But in fluidic property, in most cases we will select rho as the fluidic property. If in the question, suppose laminar flow is mentioned in your question, means then you have to choose mu as the repeating variable, right? So that that Buckingham Pi theorem method is over, and we have solved some of the problems. So whenever you are getting free time, you just go through some of the solved examples. Now today we are going to see about similitude. So here this is your third unit. The first half is over. In the second half, we have similitude and types of similitude, that is going to discuss by today, and dimensionless parameters and application of dimensionless parameter and model analysis, right? So here similitude or types of similarities. Similitude is defined as the similarity between the model and its prototype in every respect, which means that the model and prototype are completely similar. There are three types of similarities. Going into the this topic, we should know about what is the basic difference between model and prototype, right? So the real structure is called as prototype, and the small scale replica of that real structure is called as model. Either it is in magnified size, or it is small size, right? When compared to that real prototype, right, the model should be either small scale or large scale, right? So depending upon the scale ratio, it can be manufactured, right? So prototype is a real structure or real working model, but real working product, right, or structure, right? But model is the small scale replica or large scale replica of the that prototype, right? So that is the basic difference between model and prototype. Prototype is the small scale the real working structure. The real working structure is called prototype. Model is the small scale replica, right? So in geometric similarity, we are here we are discussing about the basic dimensions, right? That length scale ratio, diameter scale ratio, that kind of things we are discussing here. So the most important parameter is length ratio or length scale ratio. It is denoted by LR, which is nothing but length of prototype divided by length of model. If it is a diameter scale ratio, means the diameter of the prototype by diameter of the model. It is also considered as length scale ratio or scale ratio or length scale ratio, LR, right? So here in the length scale ratio, it is LR. So LP by LM, which is equal to breadth of prototype by breadth of model, and diameter of prototype by diameter of model. This all related to length ratio. Then we are going to see about area ratio and volume ratio. Area ratio, it is denoted by LR square, LR square, meter square na. So LR square, that is area of prototype by area of model. It is length into breadth divided by of model and as well as prototype, right? So regarding what will be given for the volume scale ratio, so it is denoted by VR, volume ratio, or LR cube, right? LR cube, see, volume. Yes, here you can see this volume scale ratio, or LRQ, which is equal to breadth of prototype divided by breadth of model the whole cube, which is equal to diameter of prototype divided by diameter of model the whole cube, right? So here it is LRQ, length scale ratio LR, area scale ratio LR square, volume scale ratio LR cube, right? So this is most important, and now we are going to see about kinematic similarity. So kinematics, you all know that it represents its velocity acceleration but without considering its force relationship, right? So that will comes under kinematics. So that is also we are discussing here, that's why it's called as kinematic similarity. Kinematic similarity means the similarity of motions between model and prototype. Thus kinematic similarity is said to exist between the model and the prototype if the ratios of the velocity and acceleration at the corresponding points in the model and the corresponding points in the prototype are same. Since the velocity and acceleration are vector quantities, hence not only the ratio of magnitude of velocity and acceleration at the corresponding points in the model and prototype should be same, but the directions of velocity and acceleration at the corresponding points in the model and prototype also should be parallel, right? So let us see, Vp1 is nothing but velocity of fluid at point 1 in prototype. Vp2 is the velocity of fluid at point 2 in prototype. And what is AP1? That is acceleration. So it is kinematics, mainly discussing about velocity and acceleration relationship. So we are putting what AP1 as acceleration of fluid at point 1 in prototype, AP2 is the acceleration of point at 2 in prototype. Similarly, M is there, M stands for model, right? So the same thing has to be represented as Vm1, Vm2, Am1, Am2, and its relationship or velocity scale ratio Vr is nothing but Vp1 by Vm1, which is equal to Vp2 divided by Vm2. Likewise, for acceleration ratio, it is AP1 by AM1, which is equal to AP2 by AM2, right? So also the direction of the velocities in the model and the prototype should be same, right? Now come to the third similarity, that is dynamic similarity. Dynamic similarity means the similarity of force between the model and prototype, right? So in the earlier cases we have discussed about kinematic similarity. It represents only the velocity and acceleration of the model as well as prototype. In dynamic similarity we are directly dealing with the force applications. So Fr equal to force ratio, Fr equal to inertia force of prototype. So there are so many forces are there: inertia force, viscous force, gravity force, right? So likewise Fi, inertia force of prototype by inertia force of model. Inertia viscous force of prototype divided by viscous force of model. Gravity force of prototype divided by gravity force of model, which all combinedly equal to force ratio, right? So that's all about today's lecture. So you just go through it. Whenever you are getting free time, just solve some problem based on working of pi theorem. Also go through Rayleigh's problem, right? So you should know how to convert that units into dimension. That part you should be thorough, then only you can able to complete the unit 3. So today we have discussed the main topic, that is similitude, in which we have discussed about what is the difference between model as well as prototype, and some similarity laws are discussed, right? So with this I am concluding my today's lecture. So thank you one and all person here.